So now we're in a whole new world of function syntax. But Python keeps it relatively simple. What we do to define a function in Python is you simply type in def, you type in the name that you want for the function, and then a list of any arguments you want. We'll discuss arguments later on. Finally, you type a colon, and it's very important to remember the colon. If you do all that correctly, and you must do that, you must include def, you must have function name, you must have parens, and you must have the colon. If you do all that incorrectly, then idle will automatically indent for you. You then add as many statements as you want, and when you are done, you will press enter twice. That's what you do in the interactive development environment. Very important, don't forget def, don't forget the colon. And indentation is absolutely vital, as we will see. So here's an example. So how did I create this originally when I was in the idle environment? I typed in def, I had the name of the function, which is pr, meaning print values. I have 3 arguments, and by the way, they don't have types. You never declare types of data in Python. And then I have my colon, very important. Now, notice how everything lines up. So I have a series of statements ending with this return statement, and they all line up. They're all indented by the same amount. If I then have the statement pr values 1, 2, 3, it will return the value 6 after printing 1, 2, 3, because that's what the function does. It adds 3 arguments together, returns the result, and it does exactly what I expect. But now I want to discuss indentation, because indentation is a very, very special in Python. Most languages, C and C++, Java, they ignore indentation for the most part because that's considered sort of a programmer prerogative. There are programmers, old C programmers, I just want to space my program how I want. I don't want to be forced to indent my code. I only indent my code when I feel like it. But in Python, you must indent all code that is at the same level of the program. For example, all the statements inside a function, they must have identical indentation. Now here's why. Python in many ways is simpler syntax. How does it keep the syntax simple? Well, it has no begin-end statement syntax. There is no begin keyword, there is no end keyword, and there are no curly braces used to tell where the function begins and ends. So how does it tell what code is part of the function and what code is outside the function? How does it possibly know? It relies on indentation, but the indentation must match exactly. So if I indent the first statement in a function by 4 spaces, all the code must be indented by 4 spaces. If I indent it by 5 spaces, all the code must be indented in 5 spaces in that function. Until I start nesting things, and we'll discuss that later. And in many ways, this is great. I mean, this is terrific for beginning programmers especially, and even for experienced programmers. They hate it at first, and then they love it. And the reason is it's good style to follow this indentation scheme. It's what programmers are taught to do. But Python says, look, you should indent it consistently anyway. We might as well just use that as the begin and end of the function. You're doing the work, you're indenting it correctly if you're a decent programmer, and we're just using that instead of curly braces. We're saving you syntax, we're simplifying the language. So that's what they do. But there are some issues. If you have tabs in your program, a tab of 4 spaces is not equivalent to 4 spaces. And this is a problem. So as you're working with Python as a programming language, try to use an editor that doesn't put in tabs, or just instead of tabs, it puts in the equivalent spaces, because you can actually create a lot of errors that way. So let's do a demo. Okay, so here I want to create a function that uses the Pythagorean theorem. And to do it correctly, I'm going to have to use def and the name and the arguments and a colon. And then I'm going to have to indent consistently. And finally, a return statement is what the function sends back. Okay, let's create a function. And as I said, idle will help you actually, which is kind of fun. And you'll see this. Idle will actually do some of the work for you. That's why I love idle so much. Def, the name of the function, parentheses, and then I have 2 arguments. I don't tell what the type is because I never declare types of data in Python. It just doesn't do that. And then a colon, colon's essential. And then, it automatically puts in indentation for me. There we go. It does that automatically. Now, what I should do is I should just keep with that indentation and not vary it. So I will now say square A. This is creating a variable within the function, so it is local to the function. It is not seen outside, but it is visible within the function. I'll say SQB equals B times itself. So I've actually got the square of A and the square of B. Every time I press return, it's going to keep the same indentation, by the way. And then I'm going to return this value, which is square A plus square of B. And then I'm going to take the square root. Well, how do I do that? I won't go into the math too much, but if I use exponentiation and raise it to the power of 1/2, that actually does take the square root. Now, to complete the function, I press enter twice. Okay, so it didn't complain. It said, I accept this definition. So now that it accepted this definition, I can say Pythag, and I'm going to give it the arguments 3 and 4. And what it does is it says I've got a triangle with one side is 3 inches, one side is 4 inches. How long is the hypotenuse? And 5.0. That's exactly what I expected. So I entered a function. I called the function, by the way. I use def to define the function. I just use the name of the function to call it. That will execute the function. It will pass 3 and 4. It will return the result, and the result will be printed. All right, I'm going to talk a little bit about global versus local variables. Global versus local variables is actually kind of difficult subject in Python, but I'm just going to keep it really simple. First of all, don't really want to use global variables a lot in Python or in most programs, by the way. Global variables are supposed to be bad, but sometimes you need them. A global variable is a variable that has a value recognized by every function simultaneously. Why would you want one? Because maybe you need different functions to communicate common values with one another. I'd advise try to avoid it, but use it if you have to. If you're going to rely on a global variable, a variable that is shared by all functions, I would declare the variable up front, and then every function that refers to this variable should use a global statement. This says it's not local. So if it's not local, it must use the global version. And if I didn't say global amount in this case, it would say, oh, this is a local variable, and it would make changes to that variable. It would not affect other functions. If you're not going to use global variables, you can basically not worry about this screen. But if you get into a complex program, you want to share information, then you're going to have to start to worry about global variables. Wouldn't worry about it too much right now. Let's review briefly how arguments are passed. The simple case is simple. When I call a function, I define a function and I call it. Remember, arguments do not have a type. Python will just let you pass any kind of data to any argument at all. It doesn't check it, so be careful. But it does simplify the syntax, and arguments are simply assigned in the order they're passed, as you can see. Finally, the return statement gives back a value. Now, this raises a potential problem in that we don't have pass by value or pass by reference, terms you might have heard of if you were working with C or BASIC or anything. Usually the language would have a special keyword or syntax for pass by reference, which means the function can return the value after permanently changing it, thereby essentially creating an out parameter. So the first time I looked at Python, and actually for the first couple of months, I said, well, how do you give back a value? Well, you have the return statement, but what if I want to change several values inside a Python function? How would I do that? I can't pass by reference, therefore I really have no out parameters. I only have in parameters. I can't take a variable and make changes to it. So what if I need to alter a bunch of data inside a function? Well, you can't do it in Python for the most part, very difficult. But what you can do is you can pass back as many values as you want. So I have a very simple function here called makeData. I can pass back multiple values. So I can set maybe 10 different parameters, 10 out parameters. I can have a function that makes all kinds of changes to all kinds of data. The only caveat here is that if it returns multiple values, I have to expect multiple values when I call the function. So I have to use this notation, A, comma, B, comma, C, to accept the 3 values that I've returned. Now, a variation on arguments, again, I said you don't declare arguments, you don't declare a type for any argument. Python just doesn't believe in that. But you can specify something called a default value. And a default value is a value that we pass to the argument if you don't specify anything during the call. So sounds a little complicated. It's incredibly simple. So I have a function called makeValue. It has a parameter A, and then it has an argument A and has an argument B. B has a default value of 0. What this means is if there is no second argument in this case, it will just assume 0. So 0 will get passed to B automatically. And that means that every function call can either pass values for both A and B, or I can just let B assume the default value, and in which case here it just says, oh, I add A and B, B by default is 0, so I'm just going to pass back 3. There is a rule that if I have default values, I can have any number of them, but they must be at the end of the argument list, so there's no confusion. Now, before we leave functions altogether, we're almost done, but there are some subtleties. A basic rule that you must keep in mind with Python functions is that before you call a function in Python, you must have a definition of that function before you can execute it. So I call a function foo, but I haven't defined it yet. Python will complain. Now, what if I have two functions where A calls B and B calls A? Isn't that a problem? Isn't that impossible? Because before I can execute A, I have to define B. Before I execute B, I have to define A. This seems impossible, and there are programs that actually do want to do this. But there's an easy solution, and this is what I recommend you do in Python when you start to get multiple functions, which you will in a program with any degree of complexity. All you do is define all your functions first. So put all your function definitions first before you execute any of the functions. And because all the functions are listed before any of the function calls, Python will be happy. You cannot go wrong. Now, an interesting feature of all functions in Python, which is tested for on the exam, is I can use the literal quote feature, the literal quotation feature, the literal string feature, to create something called a document string. Why do I want a document string? Well, it creates help. And when I'm in idle, I can get help on any type I want. I can also get help on any function I want. So if I use this feature of using a literal quotation inside a function, I can put help in for other programmers or for myself. And they can actually, at runtime, get whatever help I put in there. Whatever helpful comments I want to put in, I can put into a function. This is highly recommended. There's a couple of quirks. The documentation string must be a triple quote, creating a literal string. And it must line up in the indentation slot. It must line up with the indentation of all the other statements inside the function, as you can see here. So let's demo this. And by the way, I'll add one important comment. The beginning of the literal string, the beginning of the documentation string, must line up with the indentation. The rest of it can go over multiple lines. But let's see an actual example of this. Okay, so all I'm going to do here is I'm going to define this function again. I can redefine functions anytime I want. It won't mind. And this time I'm going to put in a doc string. What good is a doc string? Well, again, it's free help. It's also a comment. I mean, in general, it's good to put comments in your code, as I said. And the beginning of it must line up with the indentation scheme that I have here for the function. But the rest of it can be spaced anywhere. So I begin and end with 3 quote marks, creating a literal quote, which in this case will serve as a doc string. So what does this do? It does a squared plus b squared. Then I'm going to take the square root. And okay, so I defined a Pythagorean formula again. And I can go ahead and run it. But I can also get free help. I can get help on the function. And boom, tells me what it does. Right? So I documented what the function does, and it's even available within the interactive development environment because I made it a document string. So cool. One other thing before we leave the topic of functions altogether, because this is really important to the course in general. So far, I've been using the interactive development environment, and that's just awesome because it's just a fantastic learning tool. I'm going to want to save programs, and I'm going to want to run those programs at some point. That's absolutely critical. How do we do that from within IDLE? How do we create a program and then save it? Well, we use a menu command, File. We use File, New, File, Save. And then later I can bring it up with recent files. Let's go ahead and do that. So what I'm going to do is I'm going to copy this definition. It's not working, but let's try it again. Let me reboot. Let me reboot IDLE. Okay, let's recreate this. Let's do a simple version of Pythag. And let's return we'll do A star A plus B star B, which is getting me the square of these numbers. And then we're going to take the square root. See if it works. Yeah, it does. So it's working. But I want to save this program. How in the world do I do it? Well, right now it's not even a program. It's just a function definition. But let's copy that function definition and then go to File, New File. We blast this in, and we've got a function definition. But let's also call it and then print the result. Okay, so believe it or not, that's an entire program, right? It defined a function and called it. That's actually a program. And what we want to do is save it. Let's save it as Pythag. And you'll want to give it a .py extension, which I don't know if you can see, but it's there. Now I have saved a program as pythag.py. That means I can delete this, I can start over here, I can start completely over, and now I can run the program anytime I want by saying recent files, let's load pythag.py. I've loaded it, and I just go to the run menu and say run module, and boom, it prints 5.0. Not very exciting, but it actually saved and loaded a program. So I'm actually now at a higher, more advanced stage of Python programming. I'm actually saving entire programs, even if it was small, saving it on disk, loading it whenever I want, and running it. So let's summarize. Functions, that's really a whole new topic, but an important one. You can enter a function in Python, but you must enter def. The def keyword is the keyword, but you enter def, name of the function, arguments, if any, and you must end the line with a colon. If you do that, IDLE will automatically indent for you. It's absolutely critical to keep that indentation scheme consistent. It's also important to know when writing functions, there is no pass-by value, there is no pass-by reference. This is not like other computer languages. You must unlearn what you have learned. Cannot do that, but you can return as many values as you want in a return statement. So if you want your Python functions to have multiple out parameters, just return multiple values in the return statement. And also, default arguments are worth understanding. They allow people to be lazy and not enter all the arguments, but if you have default arguments, they must come last.